This video is going to cover section 8.4, inverses of matrices, but first we are going to start out with a little warm-up, kind of to review old information, how to use and multiply and add and subtract matrices. So go ahead and get out a sheet of paper and use the following matrices to perform the indicated operation, and if it cannot be done, you have to explain why. So go ahead and pause the video and then go over the answers as a class. Section 8.4 is covering the inverses of matrices. And so first we're going to recall, just with when we were learning numbers, what an inverse is. And so in real numbers, so when you guys were first learning about numbers and number sense, the number 1 is called the multiplicative identity. And what that means is we can multiply any number with 1 and we just get that same number. So a times 1 equals 1 times a equals a. That's called the multiplicative identity. Two numbers that multiply to 1 are called reciprocals or inverses. And so we're going to start using the word inverse with matrices. And so just as an example, I want you to solve this equation, 1/2 x equals 4, but I want you to solve it without using division, because we're multiplying x by 1/2, and with matrices, in order to get a matrix by itself, we can't divide. You guys learned addition, subtraction, and multiplication, but there isn't division. And so I want you to solve for x using multiplication and not division. And so in order to do that, we would multiply both sides by the inverse of 1/2, which would be 2 over 1. And what you do to one side, you have to do to the other. And so that would give us 1x equals 8, which just is x equals 8, because 1 is the multiplicative identity. We don't need to write it. And so this process of multiplying both sides by the inverse is what we need to use to solve for some matrix equations that are going to be coming up, because we can't use division. So in square matrices, so a square matrix is a 2 by 2 or a 3 by 3, a 4 by 4, where the number of rows and columns is equal. The multiplicative identity is the matrix that has 1s down the main diagonal and 0s elsewhere. And so here are the examples of just a 2 by 2 and a 3 by 3. 1s are going down the main diagonal, which is always from the top left to the bottom right, and then you have 0s everywhere else. And so if you were to take a 2 by 2 matrix and multiply it by this 1, 0, 0, 1, you would end up just getting the same matrix. Same thing with a 3 by 3. If you multiplied this multiplicative identity with a 3 by 3 matrix, you would just end up with that same matrix. And so here's just an example of multiplying by the multiplicative identity. It just gives you whatever matrix you are using. And the reason we need to know that is because we are going to be learning about matrix inverses. And two matrices are inverses if their product, a times b, is b times a. So here is where it's commutative, because before we learned that multiplication with matrices is not commutative. And that product equals the multiplicative identity, 1, 0, 0, 1. So what I want you to do is to determine if these two matrices, matrix A and B, are inverses. So I want 1/2 of the class to multiply A times B. I want the other half of the class to multiply B times A. Go ahead and pause the video to do that. I want you to do the product by hand, not using a calculator, and determine if these two matrices are inverses. So after a little bit of multiplication, you'll see that A times B is 1, 0, 0, 1, and so is B times A, and that means that A and B are inverses of one another. But how would we find the inverse if we weren't already given the inverse? And so here's how you find the inverse of a 2 by 2 matrix. So let's say matrix A is A, B, C, D, then A's inverse, and it's denoted with A to the little -1 power equals, and the formula is 1 over AD minus BC, and then in the matrix you multiply that number with the matrix D, where A and D are switched, and then you take the opposite signs of B and C, but you keep them in the same spot. That bottom part is called the determinant, and a matrix is invertible, meaning it has an inverse, if and only if this determinant doesn't equal 0, because this is 1 divided by the determinant. We can't divide by 0, and so that can't equal 0 in order for this matrix to have an inverse. If it does equal 0, then matrix A does not have an inverse. So what I want you to do is find the inverse of matrix A, given here as 2, -3, 4, -1. I've gone ahead and labeled the letters as A, B, C, D, so you can use the little formula for it. So pause the video and come back and check your answers. Okay, so the first part is the 1 divided by the determinant. Okay, so we won't do anything with the matrix yet. So we have 1 divided by, and then A times D is 2 times the -1, minus, and then B is -3 times 4. And then the matrix that I would multiply that with is switching your A and D, so -1 and 2 are switched, and then taking the opposite signs of B and C, so a +3 and a -4. This bottom is -2 minus a -12, which ends up being 10. That doesn't equal 0, so it does have an inverse, and you should have gotten -1/10, 3/10, -4/10, and 2/10. We're going to be using inverses in solving matrix equations and systems of equations. And so the first thing you need to learn is how to write a system of equations as a matrix equation, so in the form AX equals B. The first thing is to know that matrix A is your coefficient matrix, matrix X is your variable matrix, and matrix B is your constant matrix. And so for the first example, it looks like this. So you have 3x plus 2y equals 48, and 9x minus 8y equals -24. And so when I break this up into a matrix equation, I end up with the coefficients, 3, 2, 9, -8, the variable matrix, x and y, and you equal it to the constant matrix. For a 3 by 3, same process. The only thing is now you have x, y, and z. So how do we solve a system of equations using matrix inverses? When it comes to the 2 variable 2 equation systems, you'll need to know how to do this using inverses by hand. So the very first step is to write the system as a matrix equation in the form AX equals B. So practicing what we just did on the other side of your sheet. The second step is to calculate the determinant of matrix A to see if it has an inverse. If AD minus BC doesn't equal 0, then you can go ahead and go to step 3. If it does equal 0, then the system either has no solutions or infinite solutions, and so you have to solve it by hand using our algebraic techniques, equal methods, substitution, or elimination method. The third step is to calculate your A inverse using the formula from the other side of the note sheet. And the fourth step is to multiply both sides of your matrix equation from step 1 by the inverse to solve for the variables. And you need to make sure you left multiply, and what that means is matrix multiplication order matters, and so you always have to do A inverse times B, not B times A inverse. And so make sure you have the order in the right way. So the example we have here is 6x plus 5y equals 13. And 5x plus 4y equals 10. So the very first thing that we need to do is to write this into a matrix equation. And so here's matrix A, those are my coefficients. My variable matrix is x and y, and then my constant matrix is the B matrix, so 13 and 10. The second step is to calculate the determinant of matrix A to make sure that we can solve the system using matrix inverses. And so the determinant would be 6 times 4 minus 5 times 5, or 24 minus 25, which is -1. So yes, it has an inverse. The next thing I want to do is calculate what that inverse is. And so I have 1 over -1. I don't need to do the determinant again because I already found it in step 2. Switch your A and D, and then take the opposite signs of B and C. And when you multiply or distribute that -1, that's just scalar multiplication, you end up with A's inverse being -4, 5, 5, and -6. And then the last thing is to solve for x and y by multiplying the matrix A's inverse by matrix B. And so then you have -4, 5, 5, -6 times the constant matrix 13, 10. And when you do your matrix multiplication, you end up with -2, 5. The last thing that we're going to use matrix inverses for are solving systems with 3 variables and 3 equations, but the good news is here you get to use your calculator. So the very first step is, once again, to write the system as a matrix equation in the form AX equals B. The second step is to enter matrix A and matrix B into your calculator in two separate matrices. And then at the very end, all you have to do is multiply A inverse by B to solve for the variables. And your inverse button is the x to the negative 1 power. It's the fourth button down on the left. So the example that we have is x negative y plus z equals 8, 2y minus z equals negative 7, and 2x plus 3y equals 1. Just a reminder, whenever you don't have a variable, that coefficient is 0. So the very first thing I'm going to do is write my system into a matrix equation. Sorry about that line spacing there. So here are my coefficients. That's my coefficient matrix. My variable matrix is x, y, and z, and then my constant matrix is 8, negative 7, and 1. This is matrix A, matrix X, and matrix B. So go ahead and put matrix A and B into your calculator. And then when you type in matrix A and then inverse, multiply it by B, you should get x to be 2, y to be negative 1, and z to be 5. So that is it for now on section 8.4. You can use the rest of the time to begin the assignment.